So we got to find the side labeled x given the triangle. If you look at the one known angle that we've got of 60 degrees and you try to connect everything off of that angle, then my opposite side would be that x that we're looking for. And if this is my opposite side, it'd be nice to incorporate somehow some other given information here, like the 4. The 4 is adjacent to that angle that we know. And if that's the way we set up things for this problem, knowing opposite and adjacent are sides we can compare, which trig ratio comes to mind for opposite and adjacent? Okay, tangent of the angle, which in this case would be 60 degrees. Tangent of 60 would have to equal x over 4, since x is opposite and 4 is adjacent. And if you're solving for x, then you can just multiply both sides by 4. Cancels the 4's over here. And x is going to equal whatever 4 times the tangent of 60 degrees is. Now, in finding the tangent of 60 degrees, sometimes you're going to be taking a trig function and applying it to a degree measure that is not a special degree measure, and you have to use the calculator. Okay, it's the only way to do it. But since 60 degrees is one that we know, let's try to connect in those triangles we were talking about yesterday, those special ones that we were reviewing. Reviewing a 30-60 right triangle, since we're talking about 60 degrees, I make this 60, I make this 30. Then, using those side measures we talked about yesterday, how things cancel, short side would be 1, hypotenuse is 2, got root 3 over here. If I want to figure out what the tangent of 60 is, well, there's my 60 right there. Tangent's going to be opposite over adjacent, right? So opposite would be root 3, adjacent would be 1. The tangent of 60 is just root 3. So what does x equal? X equals 4 times the square root of 3. All right, if we're going to evaluate the expression, basically we're going to have expressions here where you have a special angle to work with, where you can set up a special right triangle. So since we're working with 45 degrees, let's set up a special right triangle of 45 degrees over here. With what we know about the side measures, recalling from last time, basically the congruent sides are my 1's, the hypotenuse is my root 2. And since we want to center our attention on 45 degrees, just pick one of these 45-degree angle measures to play with and start lining up your sides off of that angle measure. Okay, as we go back to what we're trying to evaluate now, sine squared of 45 degrees plus cosine squared of 45 degrees. To set this up, since I'm squaring everything, I might want to rewrite this a little bit so I can understand that I'm trying to find the sine of 45 degrees, whatever that is, and square it. And then I want to add on the cosine of 45 degrees, whatever that is, and square it. So evaluating these inside parts that are being squared, if I'm going to find the sine, I know sine is opposite over hypotenuse. So I got my triangle here. Opposite 45 is 1. Hypotenuse is root 2. This inside stuff becomes 1 over root 2. And it'd be 1 over root 2 as a quantity squared. Now for cosine, that's going to work out to be the same thing, right? Because cosine adjacent here is 1, hypotenuse root 2. Cosine is adjacent over hypotenuse. If we're trying to evaluate this, squaring out the fractions that we have, we would square our numerator over here to get 1. Square our denominator, which has that root in it, and get 2. Same thing over here. And what's our answer come out to be? 1. In the last unit when we talked about identities, you might recall that one of our identities, I'll just do this, the sine squared of, let's use x this time, plus cosine squared of x equals 1, right? So if you see that you've got the same things plugged into both of these and it's a sine squared and a cosine squared combination where you're adding, it should make sense that the answer is going to come out to be 1. Kind of clever, isn't it? Let's try another one of those. Let's take tangent squared. And let's take the tangent squared of 60 degrees. Let's add 1 onto that. Since the angle in play now is 60 degrees, set up a 30-60 right triangle to refer to. Or simply go back in your notes from yesterday and look at it. On a 30-60, small side has to be the 1, hypotenuse 2, longer leg over here, root 3. Comparing to 60 degrees, that would be down here, meaning the opposite side to that is root 3. If I set this up because of the squared part a little bit differently so I can appreciate better what's going on, I'm taking the tangent of 60 degrees, I'm squaring that, I'm adding 1. So very similar to what we just did on the last problem. Inside the parentheses here, evaluate that trig function value. Tangent is 60 degrees. How do you find a tangent? Opposite over adjacent. So opposite 60, root 3. Adjacent, 1. So you're going to have root 3 over 1, or just root 3, squared plus 1. If you square your root 3, we got 3 plus 1. Evaluating this expression, all we get is 4. Now, kind of like the last one, this was an identity. Those identities we talked about in the last unit, we had another one where it said tangent squared of x plus 1 equals secant squared of x, right? Now, I don't know how useful that one really is here to evaluate this, but if you try to make sense out of it, secant goes with cosine, right? So if we're finding cosine over here, cosine would be your adjacent over hypotenuse, right? So it'd be 1/2. But the secant would be 2, right? Because you got to flip it. So if this all equals secant squared and the secant is 2, and you square the 2, you get 4. Isn't that clever? All right, last problem for today. The last series of examples that you guys are going to encounter here, at least in the next part of the assignment, is ones where your directions say solve a right triangle. You're going to solve the right triangle. You need to be given some measurements on the triangle itself. In the early stages here doing these problems, we'll draw out the triangle for you. Let's see, what's given on this one is that we know 72 degrees is up here. We know the hypotenuse is 10. And when you're asked to solve a triangle, what that means is you need to find all the significant measurements of this triangle. That would be all your angles, and that would be all your sides. So since we only know one of the sides, it might make sense to label your other sides with some variables, maybe x, maybe y, something like that. And since we're in the early stages and we know these are right triangles, as long as we're given an angle to play with, right away you're going to know the other angle, right? What's the other angle? Okay, it's going to be 18 degrees, since all the angles in a triangle add up to give you 180. So you got your angle out of the way. Now let's figure out x, let's figure out y. how we're going to go about figuring out x or y. If you start with x, just to go in alphabetical order. Say I make all my comparisons here to set up my trig ratio off of the known angle of 72 degrees. If that's going to be the case, then the opposite side here to 72 is going to be y. If I'm starting by finding x, x is adjacent to that angle. What else is known? The other thing that is known is the hypotenuse. So if you use a trig ratio that has to do with adjacent and hypotenuse, it would make sense to use cosine. Take the cosine of 72 degrees, set that equal to the adjacent, which is x, over the hypotenuse, which is 10. Okay, we saw a similar problem earlier where to solve from here, you just multiply both sides by that denominator to clear it, meaning x is going to equal whatever 10 times the cosine of 72 degrees is. Let me see if I have that calculated. I don't have that calculated right now. So we'll just leave it as 10 cosine of 72 degrees. And understand that if we need a decimal value for that, we just punch it in the calculator, right? So there's your x. For your y, now let's see, since the y is opposite this angle I'm playing with, the 72 degrees, and I know the hypotenuse. When I'm talking opposite and hypotenuse, I'm thinking sine. I take the sine of 72 degrees, that's going to equal opposite y over hypotenuse 10. The same kind of magic unfolds, right? Multiply both sides by 10, 10's cancel, y equals 10 sine of 72 degrees. Once again, you need a decimal value, punch in your calculator, right?